Students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12 Physics Alternating Current Chapter 7 ncert Solution Part 4. Before we start with today's class, we have a humble request for you. Please subscribe, like and share our channel, and please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's class. So the first question is 7.12. In LC circuit, an, an LC circuit contains a 20 mH inductor and a 50 microfarad capacitor with an initial charge of 10 M coulomb. The resistance of the circuit is negligible. Let the inductance of the circuit is closed be t is equal to 0. Now we have to find this answer, these 5 answers. First question A is, what is the total energy stored initially? Is it conserved during LC oscillation? B. What is the nature of the frequency of the current? C. At what time is the energy stored? 1. Completely electrical. 2. Completely magnetic. Next question D. At what time is the total energy shared equally between the inductor and the capacitor? E. If a resistor is inserted in the circuit, how much energy is eventually dissipated as heat? So let us see the solution. So 5 questions are being asked. So let us write all the values given in the problem. So question number 7.12 or 7.12, inductance of the inductor. L is equal to 20 mH, which is again equal to 20 multiplied by 10 to the power minus 3 H. Next, capacitance. Capacitance of the capacitor C is equal to 50 microfarad, which is equal to 50 50 multiplied by 10 to the power minus 6 farad. initial charge on the capacitor. Initial charge on the capacitor Q is equal to 10 mc, which is equal to 10 multiplied by 10 to the power minus 3 c. These all values are given in the problem. Now let us solve the questions one by one. So part A is total energy stored initially in the circuit is given as total energy stored in the circuit initially stored initially in the circuit initially in the circuit is given by E is equal to, you have to remember these formulas. All questions are formula based question. If you remember the formula, then questions are easily solved. Direct question based on formula. So 10 into 10 to the power minus 3 upon so this whole square and 2, this is a bracket here, and 250 multiplied by 10 to the power minus 6. Upon solving, we get 1 joule. Hence, hence the total energy stored in the LC circuit will be conserved because there is no resistor connected in the circuit. Circuit. Now let us do the next sum. Next part is part B. Natural frequency of the circuit is given by the relation of the circuit is given by the relation nu is equal to 1 upon 2 pi under root LC. Please remember this formula. If you remember the formula, the sum is very easy. Just put the value now. 20 into 10 to the power minus 3 multiplied by 50 into 10 to the power 6, 10 to the power minus 6, which is equal to 10 upon 10 to the power q upon 2 pi, which is equal to 159.24 Hertz. Now, natural angular frequency natural angular frequency omega r is equal to 1 upon under root LC, which is equal to 1 upon under root, put the value of L, that is 20 into 10 to the power minus 3 multiply by 50 into 10 to the power minus 6. Upon solving, we get a value of 1 upon under root 10 to the power minus 6, which is equal to 10 to the power 3 radian per second. Hence, natural frequency of the circuit is of the circuit is 10 to the power 3 radian per second. And this is the answer for part B. Let us start with part C, the first sum of part C, first part of part C. So, in part C, for time period for time period t is equal to 1 by nu is equal to 1 by 159.24, which is equal to 6.28 ms. Total total charge on the capacitor. Total charge on the capacitor at time t. Q dash is equal to Q cos theta instead of theta 2 pi by t multiplied by t. So you have to remember this formula also. For energy stored in electrical for energy stored in a electrical for energy stored is electrical. Electrical. While we can write, therefore we can write Q dash is equal to Q. Hence, hence it can hence it can be inferred that the energy stored in the capacitor is completely capacitor is completely electrical at time is completely electrical at time t is equal to 0 t by 2 t 3t by 2, and in this way it goes. So this is the answer here. Now let us move to the second part of C. So magnetic energy is the maximum energy. Magnetic energy is the maximum when magnetic energy is the minimum is the maximum when electric charge maximum when electric charge Q dash is equal to 0. Hence, it can be inferred that the energy stored in the energy stored in the capacitor is completely magnetic at this time. Is completely magnetic at time. Capacitor is completely magnetic at time. At time t is equal to t upon 4, 3t upon 4 and 5t upon 4. In this way it will go. Let us move to the next part, D. So Q dash is given charge on the capacitor Q dash is equal to change on the capacitor when total energy is when total energy is equally shared between the capacitor shared between the capacitor and inductor at time t. Inductor at time t. When total energy is equal to the when total energy is equally shared between the indicator between the inductor between the inductor and capacitor. And the energy stored in the capacitor, the energy stored in the capacitor, the, the energy in the energy stored, the energy in the stored in the capacitor is equal to half maximum energy. Now we can write, which implies that 1 upon 2 q square so half q square upon c, which is equal to half bracket 1 q square upon 2 q upon 2c. You have to remember this formula, 1 by 4 q square upon 1 by 4 q square by c. So q dash is equal to q by under root 2. So but q by or q dash is equal to q cos 2 pi by t. Now we can write q, instead of q dash we can write q up upon root 2 q cos q cos 2 pi by t, q upon root 2 q cos 2 pi upon t I. Now we can write now we can write cos 2 pi upon t t is equal to, this is t, so is equal to 1 by root 2 is equal to cos 2 pi to n, cos 2n plus 1 pi by 4, where n is equal to 0, 1, 2, in this way it will go, and t is equal to 2 2n plus 1 t by 8. Next, hence hence total energy is equally shared between the inductor and the capacity at time t is equal to t upon 8, 3t upon 8, 5t upon 8. In this way it goes. The last part, E. So if the resistor is inserted in the circuit, if the resistor is inserted in the circuit, the circuit interested in the circuit, they then then total initial image image total initial image is dissipated as heat energy in the circuit. energy in the circuit. The resonance term, the resistance damps out of damps out of the LC oscillation. Oscillation. So we can write LC OSCILLATI oscillation. And this is the end of our session. Please subscribe, like, and share our channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification. Thank you very much for watching the videos and supporting us. Thanks.